Hello and welcome to step one. So step one's I can statement says I can find distances between points and midpoints of line segments. So we're going to break this up into two parts. First part's going to be all about distances, and second part is going to be about midpoints. So when we think about the distance of something, right? You can measure the distance of anything by, with a yardstick, or, you're taking so many steps to get from point A to point B, or how far you drive in the car to get to school every day or anywhere. But now we're going to look at what happens if we actually have a segment. So we have two different things that we can talk about. So we talked a little bit about this in the basic info notes, but just to reiterate, when we have a line segment, remember a line segment has a defined set of points, a defined set of length, okay, where a line will go past those endpoints and actually go on forever and ever and ever. So it's super important that when we think about distance, we have to define our start and our end. We can't go on and measure forever and ever and ever. We need to have this defined space. Okay? So this distance that we keep talking about, we have to have some sort of betweenness between the points, right? We can't have a random point over here and a random point over there. They have to be connected in some sort of way. So for example, on this, we could find the distance between like A and N, even A and R, but it'd be a little more difficult to figure out A and P because we don't have the line that connects them. So we have this model here. This will come up again later on, this equation. But in this specific example, we technically have three different line segments that we could find the distance of, right? We have the entire thing, this PQ, but then we also have P to M and M to Q. Okay, notice if we put PM and MQ together, we would get PQ. I always do food analogies. So like, if you take a cookie or a chocolate bar or something and you're sharing with your friends, right? You might break it up into pieces to make it easier. But once you put it back together, right, you can find the entire length of it or how big it used to be. Or sometimes even like when you're walking to your classes, right? You might walk so far and then you might stop at the water fountain, right? And fill up your water. You might pause for a second and talk to a friend and then you continue walking. That doesn't change the distance that it took you to walk from one class to the other. You took a pause, but you kept walking, and it's the total distance if we add those two up. So if we look at this first example, okay, it's asking us to find the measure, and we're going to assume that they're not drawn to scale, right? Obviously, these lengths are not 2 3/4 inches, so we're not going to know that that's that, but we're going to assume that at one point maybe it was. So we want to find EG. So EG, if we want to highlight it, goes all the way from E to G. Here we go. So we're looking at the total length, okay? So if we want, we could write that equation that we saw up above, right? If we add up all the pieces, we get the whole. So we know that EG, change the thickness of this. If we want to find EG, right, we could add up all the pieces. The pieces of EG would be from E to F and F to G. And remember, these are just segments. They're not defined specifically this way. We could have called this GE or FE or GF, right? Remember, our segment can go in either order because it's on array, okay? So then, once we write this equation, we can see that we know some of these lengths, right? Some of them are labeled, some of them are not. But we do know that from E to F, we have that it's 2 3/4 of an inch, so we can plug that right in there. FG is also 2 3/4 of an inch. And wouldn't you know, we know enough information that the only unknown length is the one we're looking for. Okay, so when we solve for EG, it's nicely already by itself. So when we add 2 3/4 together plus 2 3/4, we end up getting 5 1/2. Okay, if you want to leave it as a fraction, that would be okay. Just let's make sure we have our units. This is in inches. Okay, you could also just have 5.5 if you like using decimals too. Those are equivalent, so those would both be acceptable answers. All right, let's go ahead and, let's do this one too, actually. Slightly different, similar setup. Okay, if we want to highlight the pieces, we can kind of like up above, but we don't have to. So this time, we actually know the full length, right? We know AC, and then we have these two different pieces that this is broken up with, right? So we could say that the full piece is AC, and it's broken up as if we added A to B, B to C, right? To find length, we always add, we don't multiply. So we know A to C, that's the yellow piece, is 13.2. A to B, we don't know, so we're going to leave AB in there as if it was an unknown variable. And BC is 5.8. So setup is similar, but how we're going to solve this is a little different because AB has this piece 5.8 attached to it. So just like when you were solving a regular equation with a regular variable, we're going to subtract 5.8 on the other side. And 13.2 minus 5.8 is 7.4. Okay, and this has units, so whenever we have units, we definitely want to label those. So our answer is 7.4 meters. So that's one way we can find different distance, okay? Sometimes we might not be given the actual picture, okay? So we definitely want to draw ourselves a picture. Do not be a stickler and try to draw this to scale. We can't possibly draw it to scale because we don't know the lengths, okay? So it says find the value of A and XY. So notice, part 1, we need to find A. Part 2, we need to find XY. So we can't forget to find XY at the end. We always have to reread the question and make sure we're done. It says Y is between X and Z. So when we draw our segment, doesn't really matter how long you draw it. It doesn't even matter where you put the point in the middle. We just know that when we draw our 3 points, we have to have X and Z, and Y is somewhere in the middle. It is between them, okay? And then we have some lengths. It says between X and Y is 3A. So let's go ahead. Between X and Y is 3A. X to Z, so from the beginning all the way to the end, is 5A minus 4, and YZ is 14. So this is a very similar setup to what we had before. Okay, the only difference is now we have a variable in there, which we're going to have to solve for first. And we had to draw the picture for ourselves. Okay, so remember, if we add up all the pieces, we will get the whole. So if we want to start with writing the equation, we can, right? The pieces would be xy and yz. When we put those together, we get the full length of xz. So instead of having actual numbers for all of them, we have some expressions. So xy, it told us, was 3a. YZ is 14, and XZ was 5A minus 4. Okay, and then you're just going to rely back on those Algebra 1 skills that I know you all have. and solve this. Okay, so we can't combine any like terms. Let's subtract our 3a over 14 equals 2a minus 4. Add our 4. Divide by 2. And we get 9 equals a. If you want to, that's a weird 9, sorry. If you want to flip it around, feel free to flip it around, okay? But we know that a is 9, okay? Remember when we look back at our question, find the value of a and xy. So we have an extra step. We have to still find xy. We know that xy is what? Xy was 3 times whatever a is. Well, now we know a is 9. And we all know that 3 times 9 is 27. And we are finished with that. All right. Couple more things. So, one word that's going to come up all year is the word congruent. Okay, when we have anything that's congruent, that means that they are exactly the same size and shape. Same size and shape. So it's as if we copy and pasted it, okay? We might have what's called a rigid transformation where one of them might be like rotated or reflected or translated. It might be moved somewhere else. But if we are going to say they're congruent, it's as if, like I said, you copied and pasted it on your computer. You can rotate it, you can move it any sort of way. They can't, if they were on top of each other, you couldn't see them. So they have to be separate, but they might be turned, and that's okay. But as long as we have two segments that have the same exact length, then these are congruent. Okay? We don't have to call them the same thing. Like notice A, B, and C, D are named different things, but they are the exact same length. Okay, this word is going to come up all year, so definitely one that you want to convert to your long-term memory. Okay, the other thing is that the congruent symbol looks like an equal sign with this little like wave on top. I forget what that's called in Spanish, but so anytime you see that, that means that those are congruent, and you can assume that they are equal. Okay, we also have a distance formula. If we're looking at a number line. So sometimes you can do this a couple different ways, but if you want to actually plug in the formula, these bars here are what we call absolute values. Okay, distance can never be negative, so it has to be a positive value. Absolute value always makes everything positive. Okay, so let's do a couple of these. So we want to find BE, okay? So we can do this I'll show you a couple ways. So B is at -6 and E is at 2. So when we plug this into our equation, notice it doesn't matter the order. We could do x2 minus x1 or x1 minus x2. We're taking the absolute value, so that kind of helps. So we're going to do -6 minus 2, our absolute values. So that would be the absolute value of -8, which is 8. Okay, so that's one way if you want to memorize the equation. If you have the visual of the number line, you've learned how to do this when you started doing like addition and subtraction, right? We do like little, what are they called? Like bunny hops, right? We could have jumped like 1, 2, 3, 4, 5, 6, 7, 8, right? There's 8 little hops to get from B to E, so our distance would be 8. So just a different technique. Okay. Part B asks if CA and ED are congruent. So let's see. From C to A is CA is 1, 2, 3. E to D is 1, 2, 3, 4. Okay. We know that congruent means that these are the exact same. Obviously, 3 and 4 are not the same number. So these are not congruent. All right, last little bit, hopefully not to make this too long. We also have the distance formula. So the distance formula is going to come in handy when we need to find a distance in the coordinate plane. So on a graph, or if we are given 2 points, okay? This equation is nicely on the reference sheet for you for your end of course. So you will be given this as you need because, excuse me, you're going to get it on the state test, okay? And because we're squaring the parentheses, the order that we pick the x's and the y's also does not matter. So in this first example, oh, it's not, it's CD. All right, so we're going to have absolute value, parentheses. So our x's, remember, come first. So -4 minus 5 squared plus -6. So it would be minus a -1, which would make it a +1. Okay, so you can do this a couple different ways. If you want, you can plug this all in your calculator and figure out what it is. If you'd like to simplify the radical, you can do that too. So we could do like -4 minus 5 is -9 squared. -6 plus 1 is -5. Okay, -9 squared is 81. 5 squared is 25. So this is really the square root of 106. Okay, hopefully you know that 106 is not a perfect square. This is not going to work out to a nice number. So if you just plug the original equation into your calculator, you should get about 10.3. Go ahead and just round that to 1 decimal place. Okay, and that is everything we're going to cover about distance formula.